Okay, I have your file here. I'm going to drag it in. I hope you're able to see it.
Let's see. Yep, gotcha.
Are you able to see it, sir?
I can.
Okay, perfect. Okay. So looks like you already also added some supports or some structure.
Yeah, I try to leave those in there. You know, we can take them out. We can do it with or without.
Okay.
I'm working on revising that. Whatever you think is best.
Sure. So you're looking to program this part on a 3-axis CNC mill or router?
Yes.
Okay.
Yep, 3-axis router, yeah.
Okay, great. Okay, so here's what we would do is typically the workflow is once you have the part loaded, you want to make sure that it's in the right units that you want to work in. It appears to be in inches automatically. And you also want to make sure the part looks correct in terms of the orientation as you look at it down from the top view.
Mm-hmm.
Looking down as though you're sitting the part on the router, right? So you want to make sure that the length of the part is oriented so that the CNC has the travel available for the X and the Y axes.
Yep.
Now, if I try to go ahead and define a stock around it, you'll notice that it automatically computes the extents of all of the geometries that you have, both the solid geometries and also the wireframe geometries that you may have. So you now have the ability to exclude the wireframe, saying ignore wireframe, and then you can pick copy model box, and you'll see that it'll exclude all of the wireframe geometries that you may have used for some construction purpose or reference purposes here. It'll give you the extents of the bounding box. It tells you it's a little over 18 inches, a little over 4 inches, and then close to 1 3/4 inches. So you can actually change this here. Sorry, go ahead.
I have a question kind of immediately here. So we're cutting these parts out of some very kind of expensive hardwood, and we don't want to cut it out of a rectangle. So is it possible with Rhino Cam to set up, you know, your stock and have it not be rectangular, have it be closer to the shape of the finished piece?
Sure, I can answer the question. The answer, I would say yes and no. If you're going to be using a standard configuration of a product, the available stock definition types are box and cylinder stock. You can still contain the tool paths for roughing by drawing a boundary around the part. It could be like a silhouette of the part. You could contain it. The cutter, the tool path will stay inside the boundary and not cut all the way around the rectangular block.
Okay.
If you would like to define the stock as the silhouette of the part itself, then you can do a stock by extrusion or stock from selection. That is offered in our Pro configuration.
Okay, so I think the Pro is probably what we're considering purchasing.
Okay.
So that is possible to do stock by part silhouette in the Pro version, you said?
Yes, Pro allows you to do a stock by selection. You can even model your stock in Rhino. I can have it placed on a different layer, and I can do a stock from selection. So for example here, I can grab this part in here, right? And I can use a command called mesh outline in Rhino. So let's say, for example, I'm going to add a new layer, and then I'll just grab this part. I'll do a mesh outline. So that basically puts an outline around the part right there.
Yeah.
And I can even offset this out a little bit. I could do a simplified curve and do an offset of maybe, you know, 100 thousandths or 150 thousandths.
Yeah. Yep. Perfect. Yeah. 1/8 of an inch, something like that. Yeah.
Yeah. Or I can even do an 1/8 of an inch. And you notice that I excluded the tabs from the, you know, that you modeled from. I'm just picking up the part silhouette and I'm offsetting it by 1/8 of an inch right there.
Cool.
So now this particular sketch that you have, since I did a mesh outline, Rhino automatically places it at wherever your construction plane is, or the C plane. So you could leave it right there, and I could go into stock and use stock by extrusion, and I can specify the high and the low Z values. Or the other way you could do it is you can actually turn this into a solid model in Rhino. I could do a solid extrude planar curve straight, and I can basically snap it to the curve. So we now have a solid extrusion in here. I could select this object. I'm going to rename this layer I'll call it stock. And I'm going to highlight this object, do a stock by selection, and I'm going to just hide this layer. And now if you take a look at the display of the stock, you actually modeled a stock of a custom shape.
Oh, that is awesome. And so that feature is only available in Pro.
Yes, so this feature is available, the stock by selection and stock by extrusion is available to you in Pro configuration. You can also do a part offset stock for castings and applications like those. You can do an offset of the part, but the extrusion or stock from selection in this case is available in the Pro.
Oh, I see. So you could offset all the surfaces, like as you had sort of cast the part. Okay. So you could take that same shape and then offset it an eighth of an inch or something like that all the way around.
Absolutely. Absolutely.
Cool.
All right. So now saving the work in Rhino automatically saves all of the CAM information that you programmed to the same file as well. All right. So the next step is we want to work on programming the toolpath. So we got the stock defined. And where would you like to typically establish your XYZ origin to program this part?
Oh, it's fine where it is. There's no, I don't really have a...
Or if you want to put it to the center, the intersection of these two lines, what we could do is we can add a work window. You can use pick, and then I can use the intersection snap and just grab the intersection of those 2 points. And that could be established as your XYZ0. And you can also output your work offset number, whether it's a 54, G54, or 55 if needed. All right? So we got the work 0 set up. So this is still your origin, the WCS or the World Coordinate System origin. We just transformed the machining origin right up to this point.
Yeah.
So the next step, we want to rough it out. So we would go into the machining. We'll pick 3-axis, and we have all of these methods in 3-axis in the Pro configuration. So you have access to roughing, re-roughing, all of the advanced 3D finishing techniques as well.
Yeah, I was looking at these last night.
So we would start with the roughing process typically to bring it as close as possible to the finished shape of the part. You want to grab a tool for it. So you could specify what type of tool would you like to create. You can see I have a library of tools loaded, but I can go back and edit tools, add additional tool types in here. We have different tool types that you can create. You can also establish your feet and speeds. We have a built-in calculator. You can also set the maximum spindle RPM your CNC can handle. So, for example, it could be 18,000. You can also set the maximum cut feed rate your machine can handle. You can specify that to be, let's say, 200 inches per minute, for example.
Okay. Sounds pretty reasonable. Yeah.
And you can accept this. So if you want to change your spindle speed, or if you change your material that you're cutting here, wood, you can have different types of wood that you can establish in the list here. So you can specify, add mahogany, maple, oak. You can customize the list. Again, you can specify the maximum RPM over here.
Cool.
And establish it. That'll recompute your feed rates. And if you want to change your spindle RPM, let's say you want to go 6,000 RPM for roughing, you can recompute your cut feed rate. And all of this can be saved back to the tool. So when I pick Save Edits to Tool, this information is now updated with the tool.
Cool.
So once you have your tool selection made, you go to feeds and speeds. They're automatically updated. So you don't have to go and re-enter the feeds and speeds, or you don't have to go back and do a load from tool again. It automatically reads it from the tool.
Yep, gotcha.
The next tab is the clearance, which is your safety plane for all your transfer motions, and the system will automatically determine a safe height based on the part and the stock that you've defined. And you can also change this height to be much higher or higher if necessary. All right? So we'll go to the next tab, the cutting parameters, where you can specify your tolerances. You can choose your cutting pattern. We have core and cavity regions, so automatically use facing is selected for core regions, and for pockets and cavities, it'll use a pocket cut pattern. So you have the pocket cut pattern versus the core regions. You can specify your step overs. Under cut level.
Can you go back to that actually one more time? What was the core regions you're talking about?
The core regions are like island areas that are sticking up. So you can use a island offset cut pattern where the cutter starts from the outside and work its way in towards the core. A cavity region is like if you have a pocket that you're working in, you want to ramp into the pocket and use one of these cut pattern types. So the system can automatically identify what's a core and a cavity based on the model that you're working on.
So what does it identify here?
In this case, you see a lot of core regions. You might see a little bit of cavity area in here. In most areas, it's all a core region. So the cutter will start from the outside and work its way in towards the part.
Cool.
So I'm going to go ahead into the Cutter Levels tab. I can specify my step down, how fine you want the cutter to go a step down in Z. I could say 30% or 20%, depending on the material. How hard the material is, you want to take smaller steps.
Yeah. Gotcha.
Here, you can specify how you want to ramp into a pocket, and if you have a core, how far you want to extend out. And then you can specify your tolerances to fit arcs to toolpaths. And then finally, you pick Generate. So in this process, it automatically analyzes your stock, analyzes the part, and it figures out the areas that requires roughing. As you noticed here, I didn't have to make any selection. I didn't have to pick solids or surfaces or any of those. They're automatically processed based on the stock and the part. You see there's an overhang in here, so it can't cut from the bottom, right? So there's an undercut, right? It automatically excludes that. So now when we go into Simulate tab, we're going to run a verification in here. You hit the play button. We can also set different colors for simulation based on an operation in here, and I can apply, say for the roughing, I want to use a different color. So now when I go ahead and run a verification in here, you'll see that the roughing operation can be assigned with a specific color for the simulation process. And at any time, you can do a pause, then pick Simulate to end. It'll run through the simulation.
Now, does it have any kind of ability like I'm
sorry, go.
Does it have any ability to kind of tell how much material it's removing as it's going? I mean, does it calculate that, and is it, for example, maybe it's cutting in one spot and it's, removing X amount of material, and it's cutting over somewhere else and it's removing, 3 times X amount of material. Does it have any kind of ability?
What is called the step over and step down. So it's going to honor the parameters that you put in. So if you put in a step down of 20%, each step in the Z will not be deeper than 10%. And the step over is the distance between each pass in X and Y is set to 25%. So we don't display or estimate the volume of material being removed per pass, but we do estimate the time it'll take to machine this. If I do an information in here, it'll tell me that, for this process, it'll be a little over 21 minutes.
Okay. And then what about, like, say, like when you flip it over and you've already machined everything below sort of the center line of that piece, so all that material is now out of the way. Does it still have to go back and machine those same areas even though there's no material there?
Yeah, that's what's called re-roughing. We have that in the Pro, so it's called rest roughing operation in here, horizontal re-roughing. So it takes into account the stock that's being left from the previous step or the in-process stock. So it knows what is being left from the previous step, and it only machines the areas that the previous cutter could not get into.
So you could run multiple roughing operations using different strategies, and it would sort of understand where material had already been removed. Does that make sense? Like you could run you could run like a second roughing operation now after that first one using a different roughing strategy.
What I'm going to do here is use a larger cutter, like a 3/4 cutter first. I'll rough it out here.
Okay.
And after I run the program with the large cutter here, you may notice that in some areas it's probably
Exactly.
leaving material. I'm able to get in here. And then I'm going to go back and do a 3-axis horizontal re-roughing. And I'll pick a smaller tool, so maybe go down to a 1/4 inch. And I will change the stock to leave. I'll also drop it by just, let's say, do 10 thousandths.
Yeah, okay.
And then I can do a step down. I can use the same step down what I used earlier, which was 20% of a 3/4 inch was 0.3, 0.15. So I can use the same distance in here for the step down. And I'm going to do a fitting of arcs to the toolpath like I did before. I'm going to regenerate it. So it'll try to identify areas. And you'll notice that now it's only going into those areas where the previous cutter could not fully relieve the material. In this particular case, I also reduced the amount of stock to leave, as you noticed.
Oh, right. So it's
go back in here and put the stock to leave as the same as what I had before. Let me do that. I'm going to edit this and put it back to 25 thousandths. You'll see it'll be, clearing even less amount of material. There's, you'll notice that there's only a small area of material to be cleared out. Do you notice that, sir?
I'm not sure what you're looking at right here.
It was just the radius area that it cleaned up with the smaller cutter because I specified the stock to leave to be the same as the previous one. So if I reduce the stock, what I'm leaving, typically on a re-roughing operation, you want to reduce the stock. So from 25 to, let's say, 15 or 10,000. So you want to, try to get as close as possible to the finished shape of the part. So now here, what I'm doing is using, leaving 15 thousandths on top of the surface of the part. So you're going from a step where you did a roughing with a large cutter, and then you're going down to a next step here. So again, I can apply a different color for the simulation, so it just makes it easier to view the material that was being left. Okay?
Cool. Yep.
All right. So the next step we want to do is a pre-finishing or a finishing operation. There are several different ways you could do it. One of the areas you could use is a method called 3-axis finishing in levels, known as horizontal finishing. You could use that. So this basically creates a method called constant Z-level finishing. I can pick a tool. It could be a ball mill, like a 1/4 inch or a 1/2 inch, whatever you'd like to use. You can set your feeds and speeds, all your cutting conditions in here, and you can basically specify how fine you want the cutter to step. I'm going to put in like a 10% and pick generate. So this basically does a finishing in levels, also known as constant Z-level finishing.
Mm-hmm.
Now I can also use an option called optimized machining to mill some of these flat sections in here, or I could use a different technique to program those. Now to finish off these flats, we have a different method called clear flat machining. We could use that, or we could use a combination of different toolpath methods. With the Pro, we also have some advanced methods like 3D offset pocketing. We have curve-based machining methods. So there are several different methods you could use. So here, it's stepping down, like a waterline finishing or constant Z-level finishing. So areas where you have shallow or that are not too steep, this is probably not a very good option. So this is great for steep sections.
Right, yeah.
So it's doing a constant Z-level finishing as you notice it.
One thing I was interested in, maybe you're going to talk about this, but I was looking at this last night. It looked like in the Pro there were some features where it could sort of identify different geometries in the piece and specify like a different finishing kind of process for those so for like a really steep area, it would sort of identify that steep area and then do a particular process just in that steep area.
Mm-hmm. Yeah, you can also specify in this particular example, we could do what is called a horizontal, instead of a horizontal finishing, we could do what is called horizontal hill machining. where we can say exclude areas that are, you know, less than a certain steepness angle. So if
Yeah.
for hill machining, I could specify only machine areas that are steeper than, I could say 50 degrees, for example, and then specify the cut levels, and then generate this toolpath. So here it's going to exclude areas that are less than, the specified steepness amount. So that's one of the ways how we could, contain it. Also, we have methods where we could use, where we can specify, containment. So here now we can notice that it's excluding the areas, these areas above it
Yep.
right there, right?
Cool. So you could run one operation, like you could do the constant z-axis operation on that, and then run a different operation for the flatter area.
Absolutely. So what I'm going to do is I'm going to use this curve that we have in here. I'm going to, basically hide this stock model that we had. We should have this curve outline that we created in here, right?
Yeah.
And I could use that as a boundary and use like a 3-axis parallel finishing. And with the boundary selected, I can specify a cut direction. I could use an angle of cut, specify a step over in here, generate it. So that'll basically generate a finishing toolpath. So there's different ways how you can create it. You can also, so you have precise control in here on the type of operations that you like to program. So in this particular case, the parallel finishing and the horizontal hill machining might give you a better option in here. So I'm going to run through the simulation, and you'll notice that the hill machining basically just does those deep sections right there.
Yep.
And for the parallel finishing, I'm going to apply a different color for the simulation so you could better visualize that make it easier for the simulation.
Mm-hmm.
So I chose an angle of 45 degrees, and it gives you a nice little overlap too, and then I picked the containment, the silhouette around the part that we had. So as you take a look at it from the top view, it's going at a 45-degree angle. So,
Oh, I see.
determine the angle of cut based on the grain of the material that you're working with.
Yeah. Oh, that's cool. Yeah, I see. That makes sense.
So you could always do a pause and then pick simulate to end. So if you don't like an operation, or if you wanted to, exclude an operation, but you still want to keep it around from being posted, I can select an operation like the one I programmed in here, and I can do a suppress on it. So that's available in 2018. It's a new feature. You can suppress an operation so that can be excluded from being posted, and now you want to select your post processor from the list. And would you be able to let me know what's the controller that you're working with?
It's the Axiom Precision CNC.
Okay, so I'm going to pick this as the post processor. You can specify your output file extension as NC or CNC, whatever that is, and then you do a post. And your posted code would automatically show up in a text editor. It could be like a notepad or whatever application that you choose.
Yeah, cool.
And you can see true arcs are being output as well.
Cool.
So that would be a typical workflow in here. Now, if you have parts that are similar to these that you're going to be programming, you can save this workflow into a knowledge base. And once you have it saved, you can load those operations on other projects that you're working on. You can pick a save to knowledge base, and you can choose where you want to save it. I can call it ARM demo or whatever you want to call it, and then save it up right here. And when you have another part, you just load the knowledge base, and you just associate the operations to it. So, for example, I'm going to go ahead and save this over here. And let's say we never had any operations in here, so I'm going to go ahead and delete these operations out. And I can load my knowledge base. Let's consider that we are starting out with this new project. I'm going to open this knowledge base. You can see all of these operations are in here. And now I can generate these. And for these operations, I can associate this region in here. I can say edit. And for the parallel finishing, I want to make sure I pick this containment. And now I can go in and generate the toolpath. So if you want to make any changes, you could, but if it's not required to, then you just basically regenerate it. Now, before you regenerate a re-roughing operation, you want to make sure that the previous operation was programmed and simulated. So you would want to make sure that you simulate the roughing operation first,
right.
and then you go back and regenerate the re-roughing operation. And while it's being generated, I can generate multiple operations at the same time. We use what is called multi-threading, so you can have multiple operations being generated simultaneously.
Oh, cool. Now, what kind of system are you running there? Like, just in terms, I mean,
nothing fancy here, so let me bring up that information for you. It's just a Windows 10 machine. Intel Core i7 has about 8 gig of memory, as you see right there.
Uh-huh. Okay, cool.
Yeah. So just a desktop computer, or you could work it off a laptop, or whatever works best for you.
Yeah. Cool. So, like, okay, so if you look on the right side of that part there, there's that surface you see right there. To the left now, that lighter blue surface that's facing us.
And give you keyboard and mouse so you can actually point it out, and I can help you.
Yeah, so this surface right here.
Mm-hmm.
So this is a joint surface, right? So we're going to join this to another part. And so this area in here, I mean, this is, they need to be nice kind of curves, but it all kind of gets sanded and smoothed out later in sort of hand operations. But this area here, like if I wanted to sort of isolate this one area, for some really tight machining, like some, a 2% step over, or, just try and get that as flat a surface as possible. How might I go about doing that? I kind of want to make it its own special.
Yeah. So if I could take control back for a second here.
Yeah.
Okay. So what we could do, one of the ways you could do it here is you could define a boundary, like a containment in here, to restrict the toolpaths. So one of the ways I would do is use some of the tools in Rhino. I can use a duplicate edge command right there.
Mm-hmm.
So I extract the curve from the edge. And I can actually create a boundary in here. So I'm going to go ahead and just snap to like an endpoint in here, and maybe just throw in a boundary around the part, so that I have enough room for the cutter to get into this area.
Okay, right, that makes sense.
And I'm going to select these two curves, and I can join them together. So it says two curves joined to a closed curve. Now this horizontal finishing I had suppressed, I'm going to unsuppress this. And I'm going to pick this as my containment area. I'll go with a smaller tool, maybe an 1/8" ball mill, and then I can use a really tight step down, like a 2% or a 5% step down. And I can also control the top of cut and the bottom of cut where I want to begin the cuts from. So the top, I can leave it where it is. For the bottom, I could say I only want to go down to this level right there. Now, even though this curve is not planar, it really doesn't matter because we're going to trim it to that area. So if you now take a look at the toolpath here, it's doing a follow containment, so which means it's following the containment of the cutter. That's a new feature we've added in 2018. The previous versions had an option to retract to clearance, so each pass it would retract to clearance and then go back. So here you can do a follow containment. Now, you get a toolpath that will basically follow along the containment in here. So let's go ahead and run the simulation over here, and then I'm going to run this one. So you'll notice that you're stepping it really fine, and you're just working up.
Yeah, cool. That's great. That's cool. And then what about like maybe working with like, in adding hold downs or other kind of, fixturing, incorporating that into the model?
Sure. Like you added these geometries in here,
Yeah.
you could do something similar to that. You can add fixtures, you can add, and then basically it's not going to cut into those. So your hold downs that you model could be slightly larger than the actual hold down itself. So that way the cutter might go over it but not go into it.
Right. Yeah. Yeah.
Yeah, if you're doing profile operations, we can also do bridges and tabs so that, in a 2D operation, so when you're doing a cutout,
All right.
the part is still has some joints that are intact with the stock material unless you have a vacuum to
Yeah.
clean it down.
Cool. So one thing that I run into a lot in VCarve, which is what we're using right now, is that it's really it's frustratingly bad sometimes at calculating efficient toolpaths. And we might say run an operation on a part like this, and half of the time it's cutting in the air, or it's retracing its steps, it's doing things it's already done, or it's just kind of jumping around in the part a lot. What kind of capabilities does Rhino CAD have to really kind of create more intelligent toolpaths than VCarve?
Okay, so to answer your question, we have several different types of toolpath methods that are offered in RhinoCam. You're not just limited to certain toolpath types like, parallel finishing, which is basically, in some systems called planar finishing, with rasters back and forth following a 3D model.
Yeah.
You have a lot more capabilities and control than that. You can actually do a constant 3D offset toolpath in here. So for example, I can select this 3D offset pocketing. I can pick a boundary around the part, and I could specify a tool. It could be even a larger tool in here, and it does a uniform step over. This is also known as constant scallop machining. And you have toolpath that you can just follow along a curve, but it still follows a 3D model. It's called curve-based machining. So there's a lot of control available in some of these advanced toolpath methods, so you can precisely control how you want it to follow the geometry. So you have a wide range of methods. We can also do operations like pencil tracing. You can do, valley machining. So for example, on this particular part, you notice that I did a constant 3D step over. So it's using this curve, and it's basically performing, using that as a toolpath, to follow the curve, but then it's doing a uniform 3D step over or offset around it. You could also do what's called a pencil tracing, where you can use a small enough cutter in here to go back and clean up some of those scallops around the part. So this is an automatic way of identifying bitangencies around the part and creates a toolpath to clean them up. So as you can see here, it identified those bitangencies and created a pencil.
What's a bitangency?
A bitangency would be, consider you have the steep wall and a floor, and the angle that it forms is your bitangency. So if you go into a pencil trace, it identifies those bitangencies and creates a toolpath to clean them up.
Huh. So that is that what pencil tracing is?
I'm sorry?
Is that what pencil tracing is?
Yes, pencil tracing is like a pencil milling operation. You want to go and cleaning up, so it automatically identifies those bitangencies to do a cleanup.
Mm-hmm.
So it eliminates or reduces the need for you to do a lot of, sanding and manual finishing.
Right, yeah.
In these tight areas.
Cool.
Now over here on this area, I could use a 3-axis curve machining to get a nice finish on it. So I can use what's called curve machining, and I can pick these curve areas on the part right there. So I'm selecting just a bunch of surface edges.
Yeah.
And now I'm going to pick a tool and specify what side of the curve you would like to cut. You can go on or along. You can specify like a cutting width in here and generate the toolpath. You can see it basically follows along the curve. I could also use a method called 3D offset profiling and pick the same curve, and it'll actually follow along the curve. and you can cut the entire section where you can specify it to cut. So it's going to cut that section right there. So that's a very
Uh-huh. Oh, cool. Yeah,
I have
yeah.
all of these precise
Yeah, for
controls.
sure.
I can change this cutting bandwidth. I could have used even a method called between two curve machining, where the toolpath will morph between the two curves. So I can pick a curve around the top and then around the floor. It'll do a morph between the two curves. So that's a 3D offset profiling. We have between two curve machining, where I can pick a chain of two curves. So basically, I'm picking these two chains. So you can either pick two open curves or two closed curves, and then program
Yeah.
between the curve machining toolpath, so it morphs between the two curves. So you want to make sure
Now,
that
is it,
sorry, go ahead, sir.
was it following the surface there, or was it doing some of its own calculations and creating sort of a new surface?
Well, it's actually not creating any new surfaces here. So the toolpaths are generated based off the NURB surface that you have on the model.
Uh-huh.
So it is not adding any additional surfaces, if that's what you were asking.
Yeah. So you're kind of constraining, well, it's more than that, though. You're not just constraining the cut path. It's actually really defining the cut path based on those curves that you're picking.
Absolutely. So the curves are used for you're using the curves to drive the toolpath the way you want it, right? So it basically follows the curve.
Yeah, that is badass.
If I
Yeah,
select
okay.
these two,
You can't do that.
if you look at the directions, I'm using those two curves to guide the toolpath, but then the toolpaths are being generated onto the surface. So I'm going to pick this
Yeah,
curve,
that makes
curve right
sense.
in here. I have the start points lined up. Now when I generate my toolpath, it's going to flow between the two curves. The toolpath flows morphs from one curve to the other, but it follows the 3D model.
Oh, that
This
is
is a great
cool.
way to finish these areas and eliminate
That is great. Yeah, you're
a
right.
lot of time.
That really is awesome. Nice. Hmm.
Any other questions I can help you?
Well, I don't know. Anything else that, since we're on the phone that you would want to show me about, I don't know, maybe how it interfaces with Rhino? Because, obviously I've been going back and forth between Rhino and VCarve. That's been a huge hassle. I mean, it would seem pretty obvious.
We are staying in Rhino to do all of these processing here. So if you make a change or if you modify the part, you don't have to start all over again. You just have to go back and maybe reselect certain geometries or, just redefine your stock or reestablish a zero and then regenerate your toolpath. So it's all, I would say, it's an integrated CAM solution for Rhino, so it makes your workflow a lot easier.
Cool.
And with the Pro, you can also program from multiple setups or orientations. So similar to how you flip the part over on your machine tool, you flip the coordinate system in here. Like I say, I want to flip the coordinate system over by 180 degrees. So the coordinate system is now being flipped over. So you will now notice that as you take a look at it, if you display the coordinate system here, now it's going to be flipped over by 180 degrees. I'm going to flip it on the x-axis. You will now notice that the coordinate system is being flipped over there, right there.
Uh-huh.
And now I could basically program it from the other side. So on the machine, you're essentially flipping the part over. And now if I want to run a finishing toolpath, I'm going to just copy this operation, do a copy, and then drop it below here, paste it, and then regenerate the toolpath.
Cool. So yeah, that was kind of my question. My last question there was,
Multiple setups can be defined in the Pro.
Okay. And is that's how you would do, double-sided machining?
Yes, two-sided or multi-sided machining, absolutely. If you have a rotary table like a fourth axis, then you can actually put it on a rotary axis to do it. But in this case, if you're manually flipping it over, this is how you do it, create multiple setups to program it.
Cool. Right on. Well, great. Yeah, thank you. That's been super helpful. Would you be able to share the video file with me at some point?
Absolutely. So what I'm going to do is process the video and send you in a raw format the way it is. and then we'll probably take some time to edit it and publish it onto our YouTube channel, but we'll get you the raw
Right
video.
on.
Yeah.
Hey, fantastic. Hey, thanks, good day. Really appreciate it.
Well, sure. Was there anything else you'd like to see in the demo? And get you
No, I think that's all I've got for now, though. I mean, if I have any follow-up questions, what should I do?
You can send us an email. You have my email ID, the one that you send the file to, so you can send it to us, or you can give us a call.
The demo at Microsoft address?
That'll work.
Okay. Cool. Yeah, right on. Well, hey, I really appreciate it. That's very informative. And you have a great weekend. Yeah, I'll look forward to seeing that the video too. That'll be helpful.